So continuing on for our example using the life expectancy data to illustrate path analysis, where we left off is that we can go to setup and build the simplest syntax that shows us how we would create the path diagram if we were to use the simplest programming method. And so we can reduce that. I guess we need to keep that file window open and just keep it right south of our path diagram, because this button needs to be highlighted in order for us to run the analysis. So when we do that, we can run the analysis, and it's taking longer than I anticipated, but there it is. And now we can see our path coefficients. Now, to manipulate this so that it looks like the original diagram that we've been drawing, we can click on the little box here and we can move our life experience variable here, death rate here, doctors here, and then of course we have to can play around with arranging the arrows so that they are as we had drawn them earlier. Now, one of the things that we can do in looking at these coefficients is we like to a lot of times look at the standardized coefficients. So we can go to View and we can go to Estimations, and if we go to Standardized Solution, it will give us the standardized values. And again, we see our arrows are a little bit off from doing this, but again, we can straighten these things out. The other thing that we can do is when we go to View is we can look at the significance of our path values. So we have these t values that we can look at to see how significant these are. Actually, I guess these are the t values. They're not necessarily the significance values. We can get those from the output when we want to look at them. The other thing we can look at that this will give us is the modification indexes or indices. So, for example, if we want to improve our model, the program will give us some suggestions about other paths that we could use to make our model fit better. In this case, we don't have any other paths that would be added or deleted. Another thing I wanted to orient you to is that Lisrel produces a lot of windows, and so behind the path diagram you can see this lifeexpect.out. This is the output that you'll get in addition to the path diagram. And for this example, we get a warning message, and as I said in class, that's because we have some it looks like highly correlated variables, and so Lisrel has made an adjustment to do what's called a ridge analysis so that it can work with a matrices where you have highly correlated variables. But moving on, we get the structural equations, and so the structural equations for life expectancy is here, death rate and doctors, and then we get the covariance matrices, and we're not going to worry about that so much. But now we look at our fit indices. And so we have a lot of things to discuss in terms of interpretation and what these things mean, but I just wanted to point this out. Now, we can close these windows, and then we can actually go back and open, and we can go back to our folder. We can go to all files, and you can see these are all the files that were produced from the path analysis that we just did. So that's why it's important to keep them all in one file, because otherwise they'll be scattered all over your desktop. And so if we want to look at the output file again, we can highlight that and open it, and there it is.